Okay, today we're going to be talking about variation. And there's three types of variation that we're going to discuss. The first is called direct variation. The second is called inverse variation. And the third is called joint variation. So let's start out talking about direct variation. Direct variation happens when one variable increases, another variable also increases. They increase together, or, for example, x decreases, y also decreases. A good example of this is with water pressure. As a scuba diver's depth increases, so as he goes further down, the pressure also increases. So as depth increases, pressure increases. As depth decreases, pressure also decreases. You've probably felt this if you've gone to the bottom of a swimming pool. As you go further down, the pressure on your ears, or your whole body actually gets increases. You can feel that when your ears pop. So inverse variation is when one variable increases, the other variable decreases. So let's say, for example, speed, and this works vice versa. If x decreases, then y increases. A good example here is speed. As speed increases, the time it takes you to accomplish a task decreases. As speed decreases, in other words, if you do something slower, the time it takes for you to finish that task increases. It could be driving, it could be washing the dishes, whatever. So this is a good example of inverse variation. Joint variation is when something depends on more than one variable. So for example, but it's still, as x increases, y increases, and z also increases. Or as x decreases, y decreases, and z decreases. They vary jointly together. A good example of this is volume. Let's say I have a cylinder, and this volume of the cylinder depends on the height and the radius. So this is joint variation. Volume, radius, and height. So as the volume increases, okay, the radius and the height together, they have to increase. Oops. And if the volume decreases, together the radius and the height have to decrease. Actually, this is better said that together, so the product of the radius and the height have to increase, and the product has to decrease. And here, the volume actually doesn't just depend on the radius, but it depends on the radius squared. And the radius squared. And we'll get into that a little bit more later, because the formula for the volume of a cylinder is pi r squared times height. So it doesn't just vary jointly with the radius and the height, but it varies jointly with the radius squared and the height. So let's look a little bit more closely at direct variation. So direct variation simply says that y equals k, well, let's not use k, let's use m, because your book uses m. Y equals m times x. Oh no, it does use k. I'm sorry. I'm going to erase this again. So y equals kx. K is called your constant of variation. Okay, so k will never change. It will always be your constant of variation. So let's do an example problem here. Let's say y varies directly as x, and y equals 20 when x equals 8. When y equals 18, what does x equal? So we're going to start out solving this using this equation. So it says y varies directly as x. That means y equals kx. So I'm going to plug in 20 equals k times 8. And I don't know what my constant of variation is, so I'm going to solve for it. So I'm going to divide by 8, divide by 8. I get that k equals, what would that be? 5 over 2, right? Once you simplify 20 over 8. So now I know my equation is y equals 5 over 2x. For this problem, 5 over 2 is my constant of variation. It'll never change. So now when y equals 18, what does x equal? Well, I'm going to substitute 18 for y equals 5 over 2x, and I'm going to solve. I'm going to multiply by the reciprocal, multiply by the reciprocal. 18 times 2 is 36, so we get that x equals 36 over 5. And that would be your solution here. Now, this is one way to solve the problem. Figure out what k is, plug it in, put your other information back in the equation, and solve for what you're missing. Another way to solve is by setting up a proportion. So this is one way to solve. First way to solve. The other way to solve is setting up a proportion. When you have direct variation, imagine dividing both sides by x. Well, I would have that y over x equals k. So that means that for any y and x, I can set up a proportion. y1 over x1 is always going to equal my y2 over x2. Always. So the second way to solve this is to use a proportion. Second way to solve. And this is using a proportion. Sorry, kind of running out of room there. So I would simply say, okay, my y1 would be 20, divided by my x1 would be 8. My y2 is 18, and I don't know my x2. Cross multiply and solve. So I would get 20 times x2 equals 18 times 8. 18 times 8 is 144. Divide by 20, and we get the same answer. We get that x equals 36 over 5. Same thing. So whether you solve using a proportion, which I think is easier, it's less work, or you solve by finding k and plugging back in, you get the same thing. So that's direct variation. The second one, inverse variation. So inverse variation means that as one variable increases, the other variable decreases, and vice versa. So instead of y equals kx, like we had here, we have y equals k divided by x. And the same thing applies on these problems. I could say y varies inversely. Did I spell inversely right? I can't spell. Inversely. No, E-L-Y. Inversely. Okay. Y varies inversely as x. If y equals 25 when x equals 2, what is y when x equals, I don't know, let's say 5. So I'm going to solve this in both ways. First, I'm going to find my k, and I'm going to, and then I'm going to replug in. So we've got y equals k over x. My y is 25, so I'm going to say 25 equals k divided by 2. If y equals 25 when x equals 2, I'm going to solve. multiply by 2, multiply by 2. We get that k equals 50. So now I'm going to substitute back in. So my equation is y equals 50 divided by x. Now, what is y when x equals 5? So we simply say, okay, y equals 50 divided by 5. Easy. Y equals 10. And there's your answer. Now, doing it the second way, in this case, we're not setting up a proportion. A proportion happens when you use direct variation. Because imagine isolating k, we would have had to divide by x on both sides here. Well, here if we isolate k, we're multiplying by x. So we end up with, instead of y1 over x1, we end up with y1 times x1. So we have y1 times x1 equals y2 times x2. Now, solving here, we would just say, okay, y1's 25 times x1 was 2. y2 is what we don't know. x2 is 5. Solve, we get 50 equals y2 times 5. Divide by 5, and we get that y equals 10. Same answer, different way of thinking about it. Here you're directly using the equation and solving for k, the first way. And here you're basically multiplying by x on both sides to get k by itself. And then you're saying, okay, y times x has to equal y times x because they both would have to equal k. That's inverse variation. Joint variation. So joint variation is when you basically just have more than one variable. At the same time. So for example, y equals kx z. A classic example here is what I was just talking about with the cylinder. So let's say v varies jointly as h and the square of r. When volume equals, let's say, 20 pi inches cubed, and radius equals, let's say, 3, and height equals 5. What is, actually that doesn't make sense, hang on. Let me change this up a bit. Think about this one better first. Okay. So when v equals, let's make it 18 pi inches cubed, r equals 3, and h equals 2. So my question here is find k, the constant of variation. So I'm going to say, what is this? Volume equals k times, and it says it varies jointly as h and the square of r. So r squared times h. Volume's 18 pi equals k times our radius is 3. So 3 squared times our height is 2. So we get 18 pi equals k times 9 times 2. So 18 pi equals k times 18, divide by 18, divide by 18, and we get that k equals pi. That should make sense So that's our answer. That's our constant of variation. And that should make sense if you think back to geometry, because the formula for the volume of a cylinder is pi r squared times height. And so there's your K. Okay. I could then give you some other information, ask you to solve for volume, or ask you to solve for radius, or ask you to solve for height. But this is the general idea. So direct variation, y equals kx. Inverse variation, y equals k divided by x. And joint variation, y equals k times x times z. This just involves more variables. I'll give you one more example here that's a little bit more complicated. So let's say z varies jointly as x and the square root of y, and z equals 6 when x equals 3 and y equals 16. Find z when x equals 7 and y equals 4. So I'm going to do this in two ways. I'm going to do it with the equation. I'm going to do it using a proportion. So z varies jointly, so z equals k as x and the square root of y. So times x times square root y. Z equals 6. So I'm going to say 6 equals k times 3 times the square root of 16. I'm going to solve for k. So 6 equals k times 3 times 4, which is 12. Divide by 12. K equals 1/2. And now I'm going to plug back in. So we get z equals 1/2 x square root y. And now it tells me find z when x is 7 and y is 4. So z equals 1/2, x is 7, y is 4. So 1/2, 7 times square root of 4, well, square root of 4 is 2, 7 times 2 is 14. So that means z equals 7. And that's our final answer there. If I set up a proportion, my proportion would say z1 divided by x1 square root of y1 has to equal z2 divided by x2 square root of y2. Okay, this is kind of like direct variation because they're all being multiplied by k. If they were being divided, then instead of z over x square root y, I would have had z times square root of x, or square root of y. Okay, plugging in what we know. We've got z1 is 6, x1 is 3, y1 is 16, equals, we don't know z, divided by x2 is 7, y2 is 4. So simplifying that, 6 over 3 is 2, so we get 2 over, and square root of 16 is 4. So 2 over 4 equals z over 7 times square root of 4 is 14. I'm going to simplify and multiply by 14. So 14 times 1/2 equals z. Multiply by 14 on both sides. And we get that z equals 7. So two ways to get to the same answer. First way on the right, second way on the left using a proportion.